Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Guess the Toss. It's a medium problem of probability type. You guys can pause and go over the problem once. So right off the bat, it might seem like the probability of winning this game is 1 by 4. And since we're having to play this game giving in 1 rupee and we win 3 rupees, so the expected profit, which is essentially what we have to calculate eventually, is probability of winning, which is 1 by 4, into the expected returns in that case, which is 3, plus the probability of losing, which is 3 by 4, into 0, which would come out to be 3 by 4. And 3 by 4 is less than 1, which is the amount that we're paying to play this game. Since the expected profit is less than the amount that we initially pay, you might think that we should not play this game. But there's a better strategy that we could use so that we could increase the probability of our winning chances. And the entire trick of this game is to try to think about a strategy which increases the probability of us winning. How do you come about such a strategy? Well, for that, first of all, try to draw the sample space. So again, the essential question of the problem is basically to figure out that can we calculate or come up with a strategy where the expected profit is greater than or equal to 1, right? Because 1 is the amount of money that we're paying to play this game in the first place. Now, first, I'll be drawing out the sample space because that is important. So a strategy that will work, it must be based on what you get to see on your own coin. And this helps both of the persons A and B follow the strategy properly. Is that so? There's two possible strategies that you could come up with. The first is to guess your own coin result. Now, what does this mean? Well, try to think about each case. So, if A got a head and B got a head, what's going to happen is A is going to see his head, and according to the strategy underlined over here, he's going to guess B also got a head, and B is also going to guess that A got a head, right? And this is going to work for this case. It's also going to work for the case where both of them get tails, but it's not going to work for these two cases where both of them get different results. So as you can see that this strategy underlined over here works when both of A and B get the same result, either heads heads or tails tails, right? Out of the 4 possible outcomes. So the probability of winning in this case is 2 by 4. So that actually becomes 1 by 2. So they have half a probability of winning, which, as we talked about over here, right? Since the expected profit has to be greater than or equal to 1, and this basically just means that the probability of winning has to be greater than or equal to 1 by 3, right? Now 1 by 2 is obviously greater than 1 by 3, so this would work. Another strategy that you could have thought about was to guess the opposite of what you get. In this case, what's going to happen is, for the first case where both of them got heads, you're going to fail. And in the last case where both of them got tails, you're going to fail. But for case 2, for example, since A is going to get a heads, is going to guess tails, which is going to be correct. And since B got tails, B is going to guess heads, which is also going to be correct. So both of them are going to guess correctly. And in this case, they're going to succeed. And the exact same is going to happen in the third case too. So again, we can see a probability of 2 over 4, which is basically 1 by 2, which basically again means that the expected profit is going to be greater than 1. It's a strategy that works because no matter what happens, if A starts to guess correctly, it's guaranteed that B is also going to guess correctly. And if A guesses incorrectly, it's also guaranteed that B guesses incorrectly. Right? It's a smart trick where you end up having a probability of 1 by 2 of winning, because no matter what happens, it envelops 2 cases. Like over here, using this strategy, it's always going to be correct if both of them get the same values, and it's always going to be wrong if both of them get different values. And the probability of getting a heads heads or tails tails is 1 by 2. So it just works out. I hope you guys understood this solution, and thanks for watching.